Hello out there in remote land. Today we're going to chat about chemical weathering, right? The other day we were talking about physical weathering and actually breaking things down physically, not changing what they are. Well, chemical weathering breaks them down, but it also changes what the substance is on the chemical level, right? That's why they call it chemical weathering. Rusting is an example of that, right? The fancy word oxidation. Literally, that metal is breaking down. This other picture over here is showing you a cave underground, right? Limestone dissolves with acid rain, right? We talked about that, the calcite and the limestone, and it turns it into a different substance. So that's what we're focusing on today, all right? This is Cleopatras obelisk, as the story goes. It was in Egypt, for over 1,000 years, 2,000 years, I think. And anyway, it was carved out of limestone. And the hieroglyphics tell the story of Cleopatra's life. And it was perfectly preserved for the most part in Egypt, right? It's an arid place, a dry desert. They don't get much rain, and then when they do, it wasn't really acidic. So the limestone didn't break down. But then in the 1800s, it was brought to New York City, and it was put up in Central Park, and you can go see it, but it doesn't look like this anymore. A lot of the hieroglyphics are in pretty rough shape, and that's because, of course, of the acid rain we get here in the northeast. I'll show you what I'm talking about. There you can see one side is almost completely wiped away, right? Chemically weathered. That limestone breaks down with acid rain. So, kind of depressing. The government of Egypt at one point had said either preserve it or send it back. One of those political lovely relations there. But that is classic chemical weathering. Okay? On the plaque here, I don't know if you can read it, but it says this obelisk was erected first in Heliopolis, Egypt, 500 BC. It was removed to Alexandria, 2 BC by the Romans, presented by the Khedive of Egypt to the city of New York. Was erected in Central Park in 1881. Through the generosity of the Vanderbilt family. Anyway, it's still in Central Park, so go check it out. It's up at I want to say it's right by the Museum of Natural History on the east side. I want to say 86th Street, something like that. So check it out. So anyway, and we'll do this in the classroom, but carve your initials into the chalk. Here we have 2 pieces of chalk. We're going to put one in water, one in acid. What do you think will happen? Keep in mind, chalk is like a limestone. It's made out of calcium carbonate. It's actually the remains of dead microscopic sea creatures. So we'll carve the initials on it and throw them in the test tubes. And of course, what do you think will happen? Okay, and we'll do that in the class as well. I have a clip I want to show you as well. Okay, please read it through the different kinds of chemical weathering there. This is another form of weathering, right? The breaking down of a substance. Okay, here's your official definition. Make sure you get it in your notes. I'm sure you've all been to a cemetery, and you can see there different types of headstones, tombstones. Obviously, some are much older than others, but they're made out of different rock materials that weather at different rates. And back in the old days, sometimes they used a limestone headstone. Not realizing that it would break down a lot faster, and a lot of the writing's tough to see. Nowadays, they mostly use granite, sometimes marble, but mostly granite, sometimes basalt, to carve into it, and that lasts a lot longer than the limestone does in this climate, right? This humid climate with a lot of acid rain. Leave your bike out in the rain, and this looks very familiar to you, right? The chain rusts pretty quickly. We call that oxidation, of course, right? The rusting look. And that's the iron oxide. When it comes in contact with oxygen, it breaks it down. Okay, and you can see when the rocks have that reddish tint we've talked about, it's probably an iron in there that's rusting, and of course a nail. They rust pretty quickly when exposed to oxygen. Here you have bandings of iron in the different layers of sandstone you can see there. All right. Then we have the cave scenario. Caves are made out of limestone. They give it a fancy name, travertine, right? A cave limestone. But either way, it has calcite in it. And as the water comes through, if it's acidic, it will dissolve the rock rather, make this beautiful cave. If you build your house on top of here, that could be problematic. That's a huge problem in parts of Kentucky, lots of parts of Florida. And you get what's called a sinkhole, right, when it collapses. Okay? They call it carbonation, and carbonic acid reacts with the rocks that have calcite in them, such as limestone and marble, and it will make caves, and if it collapses, we call them sinkholes. Okay, there's a classic picture of a sinkhole there, and you could just see that limestone layer was that whiter layer there, and when it dissolved, it disappeared, and nothing was left to support above, and down it goes. Any house on top, hopefully nobody's inside, because that's going to be quite a disaster. All right, a couple others for you. There's just a higher aerial view there. This one obviously collapsed a while ago, and you have things growing inside of the sinkhole already. For scale, those are people there. Okay, and here's one where they just went in shopping or went in to come home after work, and boom, that was that, right? This parking lot must be built on top of a limestone that chemically weathered. Okay, here's another big one right there. This scenario was caught on film in the Corvette Museum. Let me see if I can bring this up here. And the limestone started to dissolve. Here we go. And I'll skip through it because it's kind of a long video, but there it goes right here. Check it out. So these are the cars before the collapse. There are a lot of pretty Corvettes. I don't know if there's any Chevy fans out there. The Corvette, of course, the classic Chevy hot rod, if you will. And then one night, February 12th, the limestone beneath the museum dissolved just enough. And there you can see the floor starting to cave in. And it'll eventually go. You could see like air kind of coming up there. And watch closely, watch closely. You can see the cars kind of shifting. And all of a sudden it's just going to go. And there it is. And it just kept going, right? The whole floor just started caving in. All said, they lost a lot of cars. I'll fast forward to the end here. Show you there are some of their recovery efforts. There they go. They pulled them out. The ones that fell later on were in much better shape than the ones that fell first. Obviously, they were deeper in the hole. And they'll pull... it doesn't want to stream that well. But the ones that they pull out later on, toward the bottom were really, really, really messed up. Anyway, that's kind of a cool view of them lifting it out. Well, anyways, pretty crazy stuff. Okay. They have since restored many of them. Some they kept, however, for the memory of it. Okay. And then there's the Statue of Liberty. Now, the Statue of Liberty we know as like a green-looking thing, but it's not supposed to be. It's supposed to be more tannish, and then the oxidation of the copper, it's made out of mostly copper, it turns green, just like iron turns red. Well, copper turns green as it's chemically weathered. And they tried to seal it. Back when I was a kid, they tried to seal it. They scraped off all the oxidation, and they put like a lacquer on it to try to stop it from happening, but it happened again. Mother Nature finds a way. All right, so then, of course, acid rain is a big culprit with chemical weathering. This is a picture of the obelisk we were just talking about, by the way. That was me a couple years back. And you can see how weathered it is because of acid rain is natural, right? We breathe out carbon dioxide, so it turns into carbonic acid in the air. But when we burn certain things, such as fossil fuels, they'll release chemicals into the atmosphere, okay? Sulfur dioxide, nitrogen oxide. And these will turn into much stronger acid rains, right, with lower pHs, stronger acids. And it speeds up the process. Okay? Then there's hydration, and this is simply just from water. Ultimately, water will break down certain materials. That's considered another form of chemical weathering. And you can see here's a piece of feldspar. And over time, it just breaks down into what looks like this pile of ooze. Feldspar is prone to chemically weathering. And it's interesting because feldspar is in granite. And granite, if you remember, is made up of quartz, feldspar. Those are the two biggies. Then there's some biotite and other things in there. But the quartz remains, but the feldspar starts to break down over time. Okay? Called hydration. Water combines with different minerals and turns hard minerals into a soft substance. There's your solid granite initially. And the pinks are the potassium feldspar, and that's what was breaking down in that last clip there. Okay? Turns it into clay. What type of climate do you think chemical weathering is most likely to occur? Well, look at this picture here. Obviously, you need a lot of moisture, but also warmer temperatures speeds up the chemical reaction. So a warm, moist climate, like a tropical rainforest, would be perfect for that. And you get a high rate of chemical weathering by the equator, of course, because it's always warm and moist. All right? The tropics, right, higher temperatures, lots of moisture, are perfect for chemically weathering. All right? When an animal dies in a tropical rainforest, it breaks down very quickly, right? It's just the reactions speed up with all that water and warmth. Okay? So here we are. Take a look at the test tubes in the room we'll show you. And of course, the one is much broken down. I'll show you a quick little clip of like a fizzing reaction, almost looking like putting an Alka-Seltzer in a cup of water. And there it goes. Right? There's your chalk totally chemically breaking down. The acid breaks it down. Okay. All right, so just a simple example of chemical weathering right there. All right, so what you guys need to do, tell me about the two different chalks, describe the type of chemical action that occurred. How is this process similar to Cleopatra's needle and other statues that we talked about? How is that process similar? And then, of course, you have a couple summary questions that follow. All right, I'll meet you back in a minute.